Good morning, guys. Am I audible?
Yeah, good morning, sir. I can hear you.
Yeah, thanks. You just now woke up? Okay, fine. Thanks for joining on time. Thanks everyone for joining on time. So let us quickly look at what is pending from the yesterday. Okay. So let's go to the interview. The first question, what is the difference between a thread and the runnable interface? So someone asked a question on which one should I prefer, implementing a runnable interface or extending a thread class, right? Do we have the person? Okay. So now let us see. So whenever you are extending a thread class, what happens? A class extends thread. Okay. Now, whenever you're using extends keyword, can you extend two classes?
No.
Or more than one?
No.
Can I say that I can? So because of this extends keyword, you cannot do multiple inheritance.
Yes.
So that is the first drawback. Okay. Now the second one. So now how this drawback will be solved in the implementing? Class implements runnable. Whenever the class implements runnable, can you implement another interface?
Yes.
So using implements keyword, you can implement any number of interfaces, correct? So that means by implementing, can I say, I can do the multiple inheritance, right? So that is the first thing why you have to go. Okay. Now, so using the runnable by creating a implementing a runnable interface and creating a thread object using runnable interface is the best way. So the first, why it is best way? If you are extending a thread class, multiple inheritance is not possible. If you are implementing a runnable interface, multiple inheritance is possible. Correct? Now, the next one. So next thing is, whenever you want to create, whether you are extending a thread class or whether you are implementing a runnable interface, what is your intention? Why do you go for these two?
To maintain a multi-threaded environment.
Yeah. So to creating a thread. So whenever you're creating a thread, where actually your program starts executing?
Start method.
So from start, it will go to the
run method.
That means so the main purpose is to override the run method and implement it, right? So then if that is the purpose, if it is getting resolved by implementing a runnable interface and overriding the run method, if you are extending a thread class, can you say obviously entire class is loaded, thread class, correct? So, and if you so the purpose of for us in a thread is implementing overriding the run method, because my thread execution starts from run method. Okay. So and the thread class will take creating a independent path of execution and all that will be taken by the thread class. But what is the purpose of runnable interface? Is you have to provide the run method. So it is like a separation of concern. So so now if you are going for a runnable, you don't need to scratch your head for other things. You just whatever the thread has to do, you will write in a run method. Now whatever the thread, how it creates an independent process and all, that is there in the thread class. You don't need to worry about it. So it provides a separation of concerns. And whenever you are extending a thread class, the object becomes heavyweight. And whenever you are implementing a runnable interface, the object becomes lightweight. So that's the reason implementing a runnable interface and creating an object would be a better approach than the extending a thread class. Okay. Any questions? Okay. Now let's go for next. Now let me tell you first this optimistic clock and pessimistic clock. So first of all, this optimistic clock and pessimistic clock is nothing. These are the concepts only. So if I say thread pool is a concept, and at the same time, we have some methods to create a thread pool in Java. Am I right?
Yes.
Yes.
Yeah. So, but for optimistic clock and this pessimistic clock, these are concepts only. When I say concept, there are no classes. So if you remember, uh, so whenever you're doing, I'm not able to recollect it. Fail safe iterator and fail fast iterator. So that is also a concept, right? So fail safe iterator will not give you the concurrent modification exception. Fail fast iterator will give you the concurrent modification exception, right? So, so it is all similar to that. It is a concept. There are no classes like a pessimistic clock or optimistic clock in Java. Okay, it's a concept way. Now, what this concept is telling, the pessimistic clock will tell you that whenever you are working with multiple threads, so each thread has to wait for another thread to complete the work on the same object, which is nothing but synchronization. For example, in if a bank, so the example that we have taken HDFC Bank, when deposit method is working, the withdraw method should go on a wait, right, on the same object, right? So that is nothing but a pessimistic log. In the pessimistic log, what happens is there are many chances that multiple threads can likely to work together on a same object. That time you have to lock one object until it completes the work. You should not allow the other object to work. So it is nothing but whatever the object lock that we have discussed. That is a pessimistic lock. And what is the optimistic lock? In the optimistic lock, what happens? So very rarely each thread, so the multiple threads can start working. So you don't need a synchronized block. But now, for example, I have a balance variable or something. So when should I go for a pessimistic clock? When should I go for an optimistic clock? Means if that balance variable is used by multiple threads very frequently, then what I have to do? I have to make the synchronized block or locking interface uh, in that method so that only one thread can execute at a time. So, for example, if the threads does not execute concurrently, very rarely it will execute. Okay. And for example, very rarely it is executing, then we say that no need to go for a synchronization block. That's correct. But the problem is, even if it is executing very rarely, it may lead to the inconsistent output. Am I right? If I am not keeping a synchronized block and the two threads are working on a same object and executing different methods, does it lead to a inconsistent output? We have seen one variable, count variable, 2000, 1500, 1600, something,
Yes.
correct? So what is
Yes.
happening in that program? In that program, so I have created two threads and one common variable is there. And if I execute one time, it is giving 2000. Another time, some 1500, some 1600, something, correct? So that is nothing but, so if I take that case, I'm assuming that multiple threads cannot work at a time. Very rarely they will work. But even if it is working very rarely, so the output may be inconsistent. So that kind of a thing is called as an optimistic lock. In that optimistic lock, you don't need to go for a synchronized block. What you can do is you can use the atomic variables. By using atomic variables, can I say you can make the output to be consistent without a synchronized block?
Yes.
Yeah, that is an optimistic lock concept. Pessimistic lock is nothing but synchronized object lock that we have written using synchronized keyword. And then we have learned read lock, write lock, and all, right? So those are nothing but a pessimistic lock. And optimistic lock is nothing but you don't need to lock that thing, but whenever the other one thread changes the value, so you have to take care of it. How do you take care? One of the mechanism is by using the atomic variables,
Atomic way.
which is a perfect way. There are other variables also, like by versioning. For example, if one thread modifies the value, then you can keep a version like one variable called version. Next time, whenever another thread is working, if the version is not matching, you can increment it. But the best way is atomic variable, because atomic variable solves the visibility problem and as well as the compound problems, right? So that is the difference between optimistic and pessimistic. There are no classes for optimistic and pessimistic clock. These are just a concept in Java. Ganesh, hope that understood.
Yes, sir.
Okay. Now let us go for fork join pool. Now, still now, what we have learned in the multi-threading, guys. So I have a huge number of tasks. If, for example, whether it's a salary calculation or triggering a email for multiple people, what am I doing? I have 1 lakh customers and I have to process their 1 lakh customers, salary for 1 lakh customers, and trigger the email or message for 1 lakh customers. Am I right?
Yes.
Okay. But assume that now, so that means, can I say that till now we were thinking about from the perspective of a customer, correct?
Yes.
So, okay, that means customer is getting a message or employee is getting a salary. Okay. Now let us think about from an insurance company perspective. So insurance company at the end of the year, they will generate a report. Am I right? In that report, they want what is the final claim amount they have provided to all the customers. It doesn't matter what is provided to Karthik, Ganesh, or like any other person, right? So they want a final report in the financial year 2022 to 21 to 22. What is the claim amount that we have given to all the customers? Now, in order to do this, can I go for multi-threading? If I have to process multiple claims, then I will go for a multi-threading, correct? If, for example,
Yes.
there are at a time 1 lakh people have submitted the claims. In order, so each claim is different for a person, correct? But I have my pending claims are 10,000. Now I have to process immediately. Then can I say immediately I will use a fixed thread pool and then work
Yes.
it? Yeah.
Yes.
But so this is from the customer point of view, correct? Now at the same time, from the insurance company point of view, can I say at the end of the year they will generate and they will see how much, what is the business they have done and all, or you have a quarterly report, right? In the share market, you can see every quarter, Infosys, TCS, all the companies, they will provide the report. What is the report in that? Do they talk about I have given the claim amount? I have given 1,000 rupees to Karthik. I have given 2,000 rupees Karthik. Or
No.
do they talk about overallly in this quarter, this much revenue we got it, and this much claim amount we have circulated, etc. Correct? Now, if I want to calculate the sum amount, claim amount of all the policies in 21, 22. Now, can I say I have 10,000 policies? I mean, like I have done the 10,000 claims processing. Can I say for each and every claim, I need to go and take the claim amount and then submit? Sum equal to sum plus claim amount, correct? And this has to
Yes.
be repeated for 10,000 claims. But again, if it is a 10,000, okay, fine. If this cannot be only a simple formula, there are so many formulas, right? Again, can I say this takes time?
Yes.
Okay. Now here, in this case, the fork join pool comes into picture. So in the fork join pool, what happens is you don't need to mention how many threads. Okay, this is one of the example of fork join pool. So what the fork join pool is will do is, so here, for example, if so internally, the fork join pool is efficient to create the threads internally. Okay. Now, so we have to, there is a fork join task, which is abstract class. We have to override one method called compute method. In the compute method, what it will do, I have to mention some threshold. Before that, see, what it will do, for example, if I have at a time, I can calculate 100 claims only. I mean, like I can do sum of 100 claims. Now, but here my claims are, let us take 500 claims are there. If I want to process, I have to split this 500 into different, each hundreds, correct? 100, 100, 100, 100, 100. If I write the for loop, if I write the program in the main method, all these for loops will be executed one after other, correct? Whatever the sum is there, on top of this sum is calculated. This sum, this sum, this sum, correct?
Yes.
Okay. But here, this is a sequential programming. It is not a parallel, correct? So, but for what fork join pool is, if your data is very huge, correct? For example, I have a claims of around 10, 1 crore claims is there. So can I write a for loop for 1 crore claims? Is that a good approach?
No.
No. Then at a time, so what the fork join pool will do is, it will do based on my processor. It will create automatically threads. So you need to tell that each thread has to create how many records. Now, for example, at a time, I can say that I can process 1,000 claims. Okay. Now it will check, first of all, whenever you are submitting the data to a fork join pool, it will check what is the, you have to submit all the tasks. Look at here. This many tasks I am submitting. I will provide, if the number of tasks are less than 1,000, then I will directly do the sum. If it is greater than 1,000, then it will generally, based on your processor, it will create left thread, right thread. Right thread will process something, left thread will process something. Let me take, instead of long number, let me take 10,000, or else let me take 4,000. So whenever I say 4,000, 4,000 by divided, is 4,000 greater than 1,000?
Yes.
Okay. Now at a time, if my records are within the 1,000 record, like 0 to 1,000, 1,000 to 2,000, that means the difference should be 1,000 only. Then only I can process it. Okay. That means at a time, only one thread can process 1,000 records. But here 4,000 is there. Now, can I say that I have to split that work?
Yes.
So that means what it will do internally, it will create a left thread, right thread. So if I do divided by 2, how many left thread should take? 2,000, correct? Right thread will take 2,000. Again, this 2,000 will be divided to 1,000, correct? Left, right, left, right. 1,000, 1,000, 1,000, 1,000. Now this, what is the sum of these 2,000? Is nothing but the sum of these two, correct? The sum of these 2,000 claims is nothing but sum of these two, correct? Now
Yes.
here it will calculate a sum and it will give here. It will calculate a sum and it will give here. And what is the 4,000 sum? Can I say that sum of these two? It will calculate and it will give it here. So this is how the fork join pool will divide the threads automatically into half, 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 and then it will sum the results of those threads. Okay, don't worry, I will explain this with a program. Let's write a program. I'm just writing fork join example. Okay. Now let us write main method. So in the main method, okay, now let me create a separate class called claim, correct? Now each claim will have a claim amount. Am I right? Private double claim amount. So what is the use case I'm doing now? Calculate the sum of all the claims for a insurance company. That means it's a year report, 1 year report. Okay. Now private double claim amount. Let's create a constructor. I don't want to create a set method. Okay, let's leave it. You can set a method also, not a problem. So done. Now what I'm saying, I have 1,000 claims, correct? What did I say? I said 1,000 claims. Now in order to create 1,000 claims, can I say that I can create an array, claims array?
Yes.
Equal to new. Let us take instead of 1,000, let me take 400. Simplest calculation. Later you can increment it. Okay. Now can I say, now I have created a claim array. Now I have to set the data to this array, correct? That means this, what does this variable will take? Claim array is a array of which is of type claim. That means at 0th position, what object will be present?
Claim object.
Claim object. At first position?
Claim object only.
So
Claim
how
object.
many objects I need to create like that?
400.
400.
So can I write a for loop?
Yes.
Okay. Why am I creating 400? Because in that year, there are 400 claims submitted by different individuals to that company. Okay. Now I have to iterate over this 400 and then I have to get the sum amount, correct? Generally, what do you think, sir? Why are you doing all of this? So you can write a 400 for loop and then sum equal to sum plus claim amount that you can write, correct? But instead this 400, if I have 1 crore or 2 crores, can I write a for loop? Is that right?
No.
No. So that's what I need some smarter programming where it can use maximum of CPU and then it can generate the output. Even if you are writing a for loop of 1 crore records, it takes time. But the problem is only the time, right? You have to reduce the time. So that's where the fork join pool comes into picture. Now in this claim array, I have to set the claim. Each of I is nothing but equal to new claim. Can I say?
Yes.
So for, I'm assuming that each claim that has been settled for 1,500 rupees. Okay, for time being. Okay. Generally, each claim will have a different amount, but I'm assuming for 1,500. Okay, done. Can I say that I have created all the I have the data ready, correct? How do you get this claim data generally? Can I say in real-time application, you have to write a database query and get it, correct? But for time being, we are hard coding because we do not have that capability of database and all. Okay. Now I have the data set ready. Now what I will do is I will create a class. There is a class called fork join pool. Look at here. In the java.util.concurrent fork join pool, there is a class. Now create an object of this class equal to new fork join pool. Okay. Now in this one fork dot, there is a method called execute. What does the execute method is taking? We have to call this method execute method. What does the execute method is taking here? Fork join task, correct? It is taking something of this object. But what is this fork join task? It's a abstract class. When I say abstract class, what it has to have some abstract method, right? Now there is some other class. Yeah. So look at here, recursive task, which is extending a fork join task. So if I want to use this fork execute method, what should I do? So this execute method is responsible to split the process automatically, and like it will create a process automatically and it will do the sum. So if I have to call this execute method, what does the execute method is taking? Some reference of fork join task, correct? Now I should do something to do this one, right? So what I will do is create a class claim processing extends so there is an abstract class called recursive task. There is a class. So this recursive class, why am I doing this? Instead of directly extending this one, so in the recursive task I'm extending. In the recursive task there is a method called compute. So whatever automatically, if I this is an abstract method, if I override it, automatically the threads will be created. The execute method will trigger the compute method. So I'm creating a class called claim processing, which is extending a recursive, and I want to do the claim processing, right? So double, because claim amount is a double. Now let's override the compute method. Okay. Now what I'm saying is, if my claims are less than 1,000, I don't need to do. See here, if the claims are around 1 crore or 2 crore, then only you need to do a headache, right? But for example, if you have the claims of 1,000, do you need to do all of this? Just write a for loop and it will work, correct? Single thread execution. You can go for multi-threads only when you have multiple, like number of claims are higher. Am I right?
Yes.
Okay. So in the claim processing, what I will do, I will create int start index or okay, int last index. Okay, now I will take int threshold equal to 100. At a time I can process the 100 records only. That is my threshold. Okay, now what I will do is claim processing. So claims array comma int start int end. So now let me pass this object here, claims array. Let's create a claims array, claim processing object, claim processing. Yeah. Equal to new claim processing. Now what I have to pass the claim array. Okay. And now what is the starting index? 0. What is the ending index? Is nothing but length. So I will say that claim array dot length. That means I am passing entire data. So then it will internally split it up and it will do the work. Why am I getting length array? 1, 2, 3. Correct. 3 parameters. First one is the array int. Okay, let's create. Okay, one more pass. Okay, start and end. Okay, this is not needed. Now, yeah, now done. Now let me pass this CL here. See, it has the compilation array is gone. Why am I getting this claim issue? Why am I getting this issue?
Reread the claim class, sir. It will.
Why it is telling it is already, the claim type is already defined. Where it is defined? Okay, let me change it. Or else. Claim. Let me take claims. Yeah. So I kept claims. Okay. I have passed here. Now in the fork join pool, in this compute method, I have to write my logic. In the compute method, what I will write is, so if what is my last is nothing but start and okay. Now let's compare this dot last equal to end. This dot start equal to start. Okay, let me keep this also as the end, better, meaningful. And claims array CL equal to null. Now what I will do? This dot claim array equal to claim array. Then I have set the data. Now, so whenever I'm getting a compute method, I'm checking what is the end minus start. If it is less than or equal to threshold, what is my threshold? Threshold is nothing but how many records I can process. Now, for example, sometimes See here, I have hard coded the data to 500, but if it is coming from the database in a particular year, I have only 100 claims. Do I need to, or if I have only limited number of claims, I don't need to do multi-threading, correct? So that is what I'm checking. If it is less than the threshold, then what I will do, I will write for, now I will create a double sum equal to 0. Sum equal to sum plus claim array dot I dot get claim amount, correct? Now, can I say this is nothing but a sum? It will give directly? Yes. Now, for example, if it is not this, now I have very large number. Now, currently what I have passed 500, but my capability is I can do at any point of time, I can do only 100 claims per thread. Now here, so it is beyond that. Then what I will do is I will create int mid equal to start minus end minus start divided by 2. This will give me my what you call the middle index. Based on the middle index, I will pass. Okay, yeah. Let me copy this quickly. So here, mid. Yeah. So claim processing. So what I will do, I will call the same constructor, and so automatically it will do claim start it's a claim array. Just a minute. Claims array. Okay. Now if you look at here, this left dot fork. So here I can at any point of time, one of my thread can work only 100 records, but I have 500 records. Then that 500 records has to be split into 2. So the left thread will take 200. Right thread will take 200. Okay, done. But still again it will check. So what is my capability? At a time I can pass 100, but what is the given? 200. So this 200 will be split into 100, left again, right again. This also will be split into left again, right again. So this will process 100, this will process 100, this will process 100, this will process 100. Now what is the sum here? Sum of these two 100 claims. This will come here. This sum of these two will come here. Okay. And then sum of these two will be the output of the program. Okay. Now let us do this. If I debug, you will get understand. So this why we keep join, because you need to complete. See, once this thread is completed, this thread can execute only when these two are completed, right? So that's the reason we have written join. So let me debug so that you will understand. Let me keep 400 records. Now let's keep here. Let's keep here also. Yeah, let us execute. Fork join pull, this one. Debug as Java application. So look at here, guys. So we have total 400 claims. I just created a data. Each claim is having what is the amount? Claim amount 1500. So I am coming out. So this is nothing but a data set preparation. So this is nothing but a data set preparation. Generally, you can get this data from the database. Now, so here, whenever I'm processing this one, can I say that I'm passing all the claim data? Am I right? Am I audible?
Yes, yes.
Yeah. So all the claims, 400 claims, 0. And what is the number of array size? Claim array dot length means 400 claims, correct? I'm passing. Then after that, what I'm doing? See, I created an object of fork join pull, and then I call the execute method. Where this will go, it will go to the compute method automatically. Look at here. Do you guys see it has created a thread? Correct? Can I say that it has created this execute method is created a thread or not?
Yes.
because it's an independent path. Look at here, where the thread is executing the compute method, right? Look at here. Now in this compute method, so whenever you create an object of this one, you have called this constructor. What are the values that you pass? You have passed start as a 0 and end as a 400. That means how many records you have currently?
400
400
records.
minus 0, 100. Now is it lesser? So that means, but your thread can process how many records at a time? Threshold I have
100.
given 100. Now can I do the execution already? All this? No, correct? So here, look at here. End minus start. 400 minus 0. It is 400. Less than my, is it less than my threshold? No. That means I cannot process, correct? I need to split this, correct? Now, generally, if I have to do a thread pool, then it is my responsibility to do it. But here, look at here. In order to make it mid, what I'm doing, see what is the mid? 200. So I think I need to keep end minus start. Okay, let me restart the program. So that execute method will create one thread. Fork join pool execute. Sorry. Look at here. It has started executing some. Now here, if I come here, so it's not. So what is my mid? 200. That means, can I say, what is it? Out of 400, I wanted to split. Whenever I split, can I say, so what at a time, the fork join pool will do two threads. That is called left thread and right thread. So if I have 400 records, since I have two threads, I am doing divided by 2. So how many records each thread should take? Left should take 200, right should take 200, correct? Now, look at here. So again, so here, again, you are calling the same constructor. And what you are passing? So this is a recursive. So you are passing the claim array. What is the start point you are passing? 0. And midpoint is nothing but 200. And next right side will take 200 to 400, correct? So that means this is nothing but 0 to 200, correct? This thread is taking. This thread is taking the records from the claim
to
array
400.
200 to 400, correct? Now, can I say I have to split again? So from here, I'm calling the constructors, I'm setting the data, correct? Yes. Left dot fork means what it will do is it will create a left thread. Look at here. Currently, how many threads are there? Main thread and this one. Left dot fork means, look at here. Does it create another thread?
Yes.
Look at here. So the current thread will see the whatever the current thread is there. This one, this will do the right sum. Sorry, right sum, and this will do the left sum. Left sum means what is the starting point, ending point? Look at here, 0, 200, correct? See, end is 200, starting is 0. That means this one is a left thread, and this currently whatever is executing, that is a right thread. Look at here. The right thread will take the right dot compute. So it will check here. See again, look at here. What is the start? 400. What is the start? 200. That means, can I say this 200, 400 is taken by the current thread, which is right, and 0 to 200 is taken by the left thread. Am I right?
Yes.
Okay. Now, so again, left should be divided again, correct? Now let us come back to the left. Let us come back to the left. Now here, if I debug, so currently 200 and 0. So can I say I'm within the threshold or beyond the threshold?
Beyond the threshold.
That means, can I say it has to be split again?
Yes.
So what is the mid you will get? 100, correct? Now can I say, now again these 200 claims are divided into left and right, and left will process 0 to 100 and right will process 100 to 200, correct?
Yes, correct.
Yeah. So now can I say here left thread, right thread, and the left dot fork means, can I say it will create one more thread towards left side, this one, and currently it will execute right one, correct?
Yes.
Look at here. See, it has created. Now look at here, the last one. What is that? 100 and 0. Now if I do F8, can I say it is calculating the sum of all the entire number? I need to pass here sum, guys. 100 and 0. Okay, look at here. So if it will see, it is iterating over the claims. Now, what is the see in the claim array you are passing I? That means, can I say the claim array is containing all the data, but from this claim ID, what are the records you are taking? You are taking from 0 to 100 and then calculating, correct? That means, can I say you are, though you are having 400 claims, are you splitting the work among the threads? And this independent process can execute parallelly, correct? Since I am debugging one thread, I am debugging at a time. But if I run the program, can I say all these threads can run parallelly? Yes or no?
Yes.
Okay. Now, if I do F8, can I say it will calculate sum? Each element is having 1500. 100 records multiplied by 1500. How much? 1500. Each claim is having 1500 amount and then 100. Can I say another 2 zeros? So 1,50,000 is the claim amount for 100 claims, correct? Now let's do F8. See what it is returning? Sorry, why it is showing 16? Okay, leave.
R calculation done.
Okay, fine. Okay, leave about the value, whatever it is. So now this sum is returned to here. Okay. Now once this sum is returned, now it will go here. Now what is this thread is taking? Look at here, 200 to 0 to 200. Now the right thread also should work, right? Let me do F8. See, that has completed. Now let us look at here. So here, what is the end point? 0. And start point? This one. Okay. I think my mistake. I have made the changes in the program, right? Written some. So it started executing. So look at here. First thread, what it will do? It will split left and right. Okay. Look at here. The current is executing right, and then the left one is 0 to 200. Okay. Now again, if I split it again, this will become into one more thread. See, the last thread will take 0 to 100, correct? Look at here, 100, and the start point is 0. Now this current thread will take 100, 101 to 100 to 200, correct? So that means, so here, if you look at here, left dot fork means it is creating a new thread automatically, and right dot compute. So here, so now why did I say left dot join? Why? So that means this current thread has to wait after the left is completed, correct? See, look at here. Now, first you are splitting 400 into 200, 200, and then 200 into 100, 100. Now, left thread, see here, right thread, current thread is doing the right thread work, okay? Now you have created a left thread. How can I get the sum of 200 claims when these two threads have been completed only, correct? What is the sum of 200
Yes.
claims? I will get only after completion of these two. Now,
Yes.
how can I make sure that this thread cannot execute unless these two are completed? Now, what is the best way? I can say join, correct? Right dot compute and then left dot join. So after left is completed, then only this current thread will come back to the execution, correct? Now look at here. First, let me execute this. See, it is executing. Now what it is returning? Some amount. Okay. Now look at here. Now it start execute. See again. See what is the end point? 200. What is the start point? 100. That means, can I say this right is working now? Correct. Now once this done, this sum will be given to here. Let's complete this. Okay. Now what is the sum? Some amount. Okay, done. If I do F8, done. See, look at here again. So left join is completed, so it will come back to the execution. So right sum, left sum will give you some amount, right? Yeah. Again, now I'm going towards right side. Okay. Now towards right side, what is the value? Let us look at. To 400 to 0 to 400. This is the main one. This one again will split. 400, 200. This is the right side one. So after completion of the left side, I am going towards the right side. So now let us do F8. So it will split again, left thread, right thread. So one thread will take 200 to 300, another thread will take 300 to 400. Look at here. 300, 200 to 300, and then this thread will take so it has completed, I think. Yeah. So let us complete this. See, it is 300 records are there. It is executing some, and then it will come back to the main thread. Now, get here. So what is the thread? And 400, and then this is 300. It is executing 100 records, and it is returning sum. So your sum will be, I should have taken the sum here. Okay, or else we can print the sum here after that. So the fork join pool, what is the use of this fork join pool is, generally the thread pool we use to split the work whenever we have to do multiple like salary calculation or triggering an email for multiple people. Then what do? We use a thread pool. But now the scenario I have given you is we have to do the reports. When I say year-end reports, we have to do. In order to do the year-end reports, you have the large amount of data. So when you have the large amount of data, so the best way is you can use a fork join pool. In the fork join pool, whatever you see, whenever you say execute method, it will create. So fork join pool is a class, and you have to use the execute method, which is taking fork join task. Okay. Now this execute method is responsible to create an independent path of execution. And this execute method will directly go the control into the compute method. This compute is abstract method in the recursive task. This recursive task is internally extending from fork join task. So whatever the code you want to write multi-threading, that means automatically splitting the data and then doing the computation, you have to put that code into the compute method. So this is the, and the thing is, in the thread pool, how does the work, threads will take the work? How does the thread will take the work in the thread pool? Internally, what we use?
Queue.
Queue concept, correct? All the threads are taking the work from the queue. But in the fork join pool, what happens is, there is some algorithm called work stealing algorithm. So it internally uses a work stealing algorithm. That means, for example, there are two, say left thread, right thread we have, right? So if the left thread is busy, okay, and what the right thread can do, it can steal the work from the left thread. That means if the left thread is busy or went into a wait mode or something, then right thread can take the work from the left thread and then do it. So instead, like it won't use the queue concept, but it uses the work stealing algorithm. What is the work stealing algorithm? If a thread is busy, another thread can take the work from it. So in the thread pool, what happens? All the threads will take the work from the queue only. But in the fork join pool, what happens? If the threads are busy, and for example, there are two threads, left and right. Left is executing and right is busy. Now what, after completion of left execution, it will become free. When the left is free, then it can take the work from the right also. And the main thing of fork join pool is you are splitting. See here, what is the work here? I have 1,500 records or 1 lakh records. You are splitting this work into a parallel programming, parallel processing, correct? You are splitting that work into smaller chunks, and that chunks you are doing the multi-threading with a fork join pool. So that is the advantage of fork join pool and how it is different from thread pool. Does it understood?
Yes, Karthik.
Okay.
So
So
once it is done, it will die that thread, right?
Yeah, automatically, yes.
But in the thread pool, it will not die.
You have to call the shutdown method.
Correct.
Yeah. Okay.
Can we pause the
Can you please be a little loud? I can't hear you.
yeah, can we pass can we have it example like runnable run task?
You don't need to do all of those. That is taking, you are writing whatever you have to do in the compute method, right?
Okay, so
So whenever I say fork join dot execute, can I say it has created an independent path, correct?
yes.
If you debug, let me show you. See, what is why you are using a runnable or callable? For having the independent path of execution, correct?
Yeah.
Now look at here. Whenever I say, see, currently main thread is executing. If I say F8, see, does it create a separate process?
Okay.
And from this separate process, see here, you have a chunk of data, large amount of data. Then you are writing some mechanism like splitting the data. And then how, by calling the fork method, it will create a separate thread automatically. And it will make sure that the sum, it will do the sum. And like after completion of this data, the 4,400 is divided into 200, 200, and 200 is divided into 100, 100, and this sum is added to the above thread. That sum is added to the above thread. So it creates this left.fork will create an internal thread. Look at here. So you don't need to write a runnable, right? Because runnable is used for whatever the code you want to do the this processing, that you have to write in a compute method. Okay. Now let's say, look at here, left.fork. Is it created one more thread? It depends on the number of records. It will create multiple threads and then it will do. So here, whenever I'm debugging, you have to select this thread. But if I run the program, can I say automatically this thread, this chunk of data will be divided parallelly among the threads and then run? Yes or no?
Yeah.
If I run the program, see here, if it is a for loop has to be executed 1 crore times. But that for 1 crore records will be divided into like any multiple number of threads, and those can work parallelly, and then the result can be summed up later, correct? So that is the beauty of a fork join pull. Okay. Now let's go for cyclic barrier. Now, okay, so what is a cyclic barrier? Cyclic barrier is nothing but, so if I take one, okay, do you guys know insurance LIC company, right? In the LIC we have agents, correct? LIC agent will be there. Do you aware? They will come to you and they will explain all the benefits of the policy. Okay. Now, for example, immediately what the agent will do, he has to complete the paperwork, correct? And then only claims a policy will be issued, right? Now, for example, on a single day, if a number of like if the policy issuance should start, then what happened? It has to wait for all the agents to complete the work, correct? So a policy
Yes.
issuance process will start only, or claim process will start only after all the agents have completed their paperwork. Am I right?
Yes.
So if that is the scenario, if I am taking that multiple agents as a thread, so the cyclic barrier will tell you that. So after, like, it will wait for all the threads to reach a barrier, and then it will resume the rest of the program. So for example, so here LIC agent has to complete the paperwork. Complete the paperwork. In order to complete the paperwork, after completing the paperwork only, processing claim or policy process starts. Okay. Now, if this is a use case, then, so here, for example, I have 3 agents. Now this policy issuance process, I am assuming that I will do this claim process or policy issuance process once in a day. Now, maybe at 4 p.m. Okay. By 4 p.m., all these people have to complete their paperwork, correct?
Yes.
So that means before 4 p.m., see, this claim process can only start after these 3 people have completed their paperwork, right? Now, in order to do this one, so assume that these 3 people are nothing but 3 threads. So what the cyclic barrier will do is, it will wait this process until the threads have reached this completion of the work. So that is nothing but a cyclic barrier. So barrier itself is nothing but something is stopping, correct? The English meaning of a barrier is itself is nothing but it's a stop or something, right? So let me show you the program.
So countdown latch also working the same, right?
Now countdown latch is not. Countdown latch is making sure that
all
after
the threads,
now
all the
here
threads should complete.
So here what happens is, see, here, countdown latch is making sure that all the threads have completed the work before other thread starts, correct? Here, all the threads have not completing the work. They are, see here, in the same process only, they are waiting for all the threads to come to a common point. See, entire program is in the single thread execution only, but I hope you understand the difference. See,
Yes, yes.
the same example you can do with the 2 threads. Then you can go for a countdown latch. Okay. Now, if I am doing it in a single thread, then before in the single thread, before the policy process starts, all this agent thread has to wait, correct? For example, one person has completed the work. Still the claim process will start? No. Second agent, third agent. Whenever the third agent completes the work, then only the claim process will start, right? So that's the one. Let me show you. You can understand. Now, cyclic barrier, there is a class in Java. Okay, let me. So we have a class called cyclic barrier. So look at here. We have a class called cyclic barrier in Java. Okay. Now it is taking a runnable interface. Look at here. If I have a constructor means, can I say it is a class only? Look at here. Public class cyclic barrier. And guys, I wanted to tell you that fork join pool is introduced in 1.7. Okay. Now, so cyclic barrier is a class and it has an interface called runnable. So now let me show you. Okay. So here I have taken number of agents as 3. Okay. Now I am creating a cyclic barrier object. Since it is a class, can I create an object like this? Yes. Now I am passing cyclic barrier number of agents 3. And then what is this cyclic barrier is taking? Runnable action, correct? So runnable means, can I say anonymous inner class I can pass?
Yes.
Look at here. I have created a new runnable. So and in this one, I am writing run method. All agents have completed their paperwork. Claim processing can begin. So this is a method I have written. Done. Okay. So this is my cyclic barrier code. Okay. And I have written this in the constructor of the example cyclic barrier. Done. Now, generally, whenever see, okay. So now look at here. Now, example cyclic barrier. Now process the claim. Now process the claim means, in this process claim method, I have a class called agent, say implementing runnable interface. And each agent will have an agent number something. Now see, in the override run method, first agent thread is started working, is completing the paperwork. Agent now here, so barrier dot await, this will see, I did not write multiple threads, guys. In the same thread only, barrier dot await. So let me, if I debug, you will understand better. So here, this is just a class, correct? I'm creating an object. Whenever I create an object, constructor will be called. So in the example, cyclic barrier, so what I'm creating a cyclic barrier object. Okay. Now, how am I creating an object? I have 3 agents, right? So I want the 3 agents to complete their work. So I'm implementing a runnable interface. That's it. Okay. Now, whenever I say process claim is a method. Inside the process claim method, what am I doing? I'm creating a 3 threads. Look at here. My agent is a class which is implementing a runnable interface. That means if I create thread agent equal to new thread of agent dot start means it will create a 3 threads. Now in the agent run method, keep the debugger. Yes, it is there. Now see, look at here. Say first agent, second agent, third agent. Can I say my 3 agents are working? Right? In the example that I have given, so every day 4 p.m. the policy issuance process will start. Before this policy issuance process starts, I have to make sure that all agents have completed their paperwork. Correct? In this example, how many agents are there? I have 3 agents. 3 agents are nothing but 3 threads. So can I say that 3 threads? See, the first thread agent is completing the paperwork. He's not completed. He's completing the paperwork. Okay. Now, second agent, he's also completing the paperwork. Third one, he's also completing the paperwork. But have they completed? No. So see here, by the time first, for example, if the first one has completed, then immediately policy cannot start. So it has to wait for all the things to complete. Then look at here, what will happen in the thread 0. So it is sleeping. So here, assume that first agent is very fast and he has completed the work. So if I don't write this code immediately, my whatever the policy process is that will start. Correct. Now I see, since one person, I want all the threads to come to a common point and wait. So if all the threads has come to a common point, then only I will start. For example, you have 3 friends, including you 4. So you 4 friends are planning to go from somewhere. If you are going, so you will call them and then say that, hey, please wait near the Begumpet, right? So once all of you have reached Begumpet, then only you will start going from there to some other place. Am I right? Now, for example, first Karthik has reached to the Begumpet. He has to wait or he can go. He has to wait for others, right? Now, similarly, look at here. So using the cyclic barrier, what it will do, it will create a stop until all the threads have reached a common place. Now here barrier dot await. When I say here, it will look at here. It will go into a wait mode. Look at here, stepping, because thread 0 has come first. Karthik has come first. I have to wait. So agent 1 is waiting. Now agent 2. So agent 2 has completed the work. Maybe he has come after 10 minutes and he can he go? No, he has to wait and for another 2 people has to come, right? So again, it is waiting. Look at here. Now, so can I say how many agents are there? 3. So if the third person comes, can I say that all have reached? All have reached Begumpet? Yes. Now immediately we can start. So await will release the lock. No, look at here. So this will release the lock and all others will start executing. Look at here. It is executing. See, it has come automatically. This await method will come to the cyclic barrier run method, and then it will execute whatever the policy issuance process. All agents have completed their work. Claim process can begin. Now let's do F8. See, it is executing all the things. Right? See, it has come out from the method. Hope you understand. So it is nothing but, so if you want the threads to come to, all the threads has to come to some point and then wait for remaining process. So that's where the cyclic barrier comes into picture. The best example you can remember is wherever you want to go with your family or friends, you will select a common place. And once everyone has reached to the common place, and then only you can start. Does this happen to your life?
Yes.
So whenever you're going for your friend's marriage or something, you might be 3 or 4 of you are speaking to each other and you will find a common place. Once everyone has reached the common place, then only you can start from there, correct? The same thing in the cyclic barrier means the cyclic barrier will make sure that all the threads have reached to a common place, and then it will resume the execution. So in order to do that, the cyclic barrier dot await method. This method will make all the threads into a waiting mode until all have come. Say whatever how can this barrier will know how many threads in the constructor you are setting number of agents, right? So whatever the threads you are providing in the constructor, this barrier will make sure that this await method will make sure that all the threads will go into a wait mode until all have reached. Once all have reached, then it will start executing this run method or this run method. So now generally, whenever I call the start method, run method will be triggered. Now in the cyclic barrier, it is constructor is taking a runnable interface. Then the question is, who will trigger this run method? This run method will be triggered by await method when all the threads have reached to a common point. So this is happening in the entire single thread processing. Ganesh, hope your question is resolved.
Yes, sir.
Countdown latch will make sure that all the pool threads have completed, correct?
Yes, yes.
But in the cyclic barrier, so the barrier will wait for all the threads to come to a common point and then execute it. Okay, so if you want to remember, you remember example of that you are going into your friend's marriage and you are waiting for all other friends to come.
Yes.
Okay. Any questions? Okay. So there is one topic called threads group. Thread group is nothing but simple one, right? Let me show you quickly. So here, thread T equal to new thread. Do you see this constructor, guys?
Yes.
Thread. So first you need to create a thread group. Okay. And then that thread group, see here, if I have to use this constructor, what does it mean? I have to thread. So let's go here. So what it is doing, thread. What is a thread group? Let's look at here. Thread group is a class, correct? First, see, the thread group is to group the threads together into one place. New thread group. Okay, and you can give the name. First set of threads. Okay, now and now you want to create one TG1. Okay, now you want to give a T1 thread you want to create, and this T1 thread you want to keep under TG1. Then what you can do? TG1 comma new runnable. Done. So this, what is the meaning here? So this TG1 thread you have created, and it is part of thread group. Okay, thread group is nothing but it can hold the like under the thread group you can have multiple threads. Now what is the advantage of this one is, so generally if I have to start a thread, what should I do? T1 dot start, T2 dot start, correct? Now, and if I want to set a priority everything, so can I say directly? So if I want to stop all the threads in that one, I can do TG1 dot stop. If I want to set a priority, look at here, set a priority. If I want to set a name, I can, oh, sorry, name is not there. Set priority. Yeah. So you can suspend all the threads. So if you suspend the thread group, then all the threads under this thread group will be suspended at once. So the advantage of thread groups is some of the operations you can perform at a time on all the threads. So look at here, these are the methods, but generally used methods are, look at here. Set demon, set max priority, suspend, check access, destroy. Yeah. So these are the methods that you can use on the thread group. So thread group is a one class. You can create the whatever the name that you have given. Under the thread group, you can add multiple threads. So the advantage here, some of the operations you can do at a time. That's the only thing. But generally, we don't use thread group. We use a executor framework more frequently. If you want to assign a thread to a thread group, you need to call this constructor in the thread class. If you go to the thread class, so there is a constructor which takes a argument as a thread group. You have to call this. Any questions? Okay. Now let me tell you one example. Now here we have done the object lock, class lock, right? Our multi-threading program. Where is that multi-threading? Yeah, thread pool, right? Now in this multi-threading, guys, so I have used ex.submit method, right? So in this one, there is one more method called invoke. So this invoke all method is created newly in the Java 8. So submit method or invoke method. Look at here. In what does the invoke call method is taking? It is taking a collection, and which is extending a callable statement. So you can use the submit method, or you can also use a invoke call method. If you want to use a invoke call method, then what you have to do, ex dot invoke all, and you need to pass this. Okay, what you can do is you can create an array. So this invoke all method is taking a collection object which implements callable or callable. Now, in my class, in this example, which class is implementing callable or runnable?
Trigger email for policy.
See, is this a collection object or normal a class?
It's a single object.
So how can I make? But this is taking a collection of classes, class which is implementing a callable. Now, how can I make this into a collection? Can I say I can create a list, correct? List which takes this as an object. Okay. Now, work list equal to new. Array list is a collection object. Am I right?
Yes.
Okay. Now, can I say that here work list dot add t, correct? Now, I don't want to do this. I'm like, let me comment for time being. And then can I pass this work list here directly?
Yes.
Yeah. So this is another way. It gives some error. Okay. You can add interrupted exception. Okay. So this is a new method that is introduced in the Java 8. In the Java 8, in the executor framework, they have introduced a method called invoke all. It is same as submit method only. Only the thing is submit method will take a individual object. Invoke all method will take a collection object, which is the collection. What is the generics of that collection is a class which is implementing a callable interface. So this is one change that is made to the Java 8. Any questions? You don't need to. So your for loop is to iterate the data and then add the data to the collection. And then you can externally call this invoke all method. And this invoke all method is also returning future only, guys. So it will return like this. It is returning a list of futures only, correct? So no issues. And whatever the object you pass it, automatically it will come. Look at here, L you can take. So look at here. If it is something different, see what is my L? L is nothing but list of futures. I can take that list of futures. So it is not like you don't get a return type, you will get a return type. Okay. Any questions on this invoke all?
No, sir.
Okay. Now there is one more last one, yield method, right? It is there. We discussed about the start method, but we did not discuss about the yield method, right? I think it is somewhere here. Yeah, yield method. Yeah. Now let us tell you yield method example. So what does the yield method will do is, see, at any point of time, do you guys can predict which thread will execute?
No.
No. But so one of the priority that scheduler will take to consider is thread priority. It is not 100% true, but it takes that. Okay. Thread. Okay. Now what I am creating 3 thread objects. Look at here. Thread ex1 equal to t1 equal to new thread ex1. Can I say I have one thread object?
Yes.
2, 3, 4. Okay. Now T2, T3, T4. How can I get a set a priority to a thread? Set priority.
method.
Yeah. So first T1 thread, I want to give the priority as low. Okay. Now then T2 thread dot priority as 10. Okay. T3, T4. Okay. Now T4, T3 I will give 8. And T4 I will give 4. Okay. Now can I say that I can do T1 dot start? Okay. Now I have started. Now, so it will go here. Now here I want to print sys out thread. Now let me keep the thread name also, correct? So that we'll get to know. T1 dot set name T1, T2, T3, T4, T2, T3, T4. Okay. Now I have set all the names to a thread. Now in the EX1, how can I get a thread name?
Current thread dot get name.
Thread dot current thread
Current
dot
thread.
get name. Okay. So what happens is whenever you say yield method, now let me show you the nodes also. I think it is not there. Okay. Not a problem. So I will write and I will give you. Okay. So whenever you say thread dot yield. Okay, now in this one, so currently one thread will execute. Okay, what I will do? Look at here. If I am accessing the yield method with a class name, what does it mean?
Static class.
Static
Static
class or
method.
static?
Static
Yeah,
method.
yield method is a static method. Okay. Now, whenever I say thread dot yield, am I telling that so what happens is after completion of the current thread, whichever the thread that will have the higher priority, it will give the access to the thread. Okay. Now, at any point of time, one thread will execute, right? So it may be, so it depends on the scheduler. For example, scheduler is taking T1 thread. Okay. Now, after completion of a T1 thread, then what happens? It will give the access to the thread which is having the more priority or current higher priority or more priority than the current execution of thread. But we cannot guarantee that. It all depends on the scheduler only. Okay. So now let us run the program and see. Look at here. So hi is printed. First T3 started executing. Okay. Now after that it has T1, T4 and T2. So here, whenever I'm run the program, you don't see that you might be seeing that first T1, T3 executed and T1. No, these are the parallel executions are happening, correct? So now let us say, if you run the program again, the output might be different. See, now T1, see for example, if you can understand that when I say T1 dot set priority and all, T1 thread started executing it. Okay, what is the priority of a T1 thread? 1. Now, whenever it is executing, can I say it will say that thread dot yield? Yeah. Whenever it says thread dot yield, what happens is it will check is there any other thread which is having the priority greater than the current thread. Current thread is T1. What is the priority of a T1 thread?
1.
1. Correct. Now, is there any other thread which is having the higher priority than the T1 thread? T2. Correct. Which is having higher stuff all. So then it will request for the scheduler to please execute 3.2, but it cannot guarantee. It cannot guarantee. It's one of the factor that it can trigger. Okay. Now let us look at again. The output will be changing. Correct. Look at here. See, T3 is executing and some other thread has completed the work. Correct. So the yield method, what it will do is, let me show you the definition in some other notes. Yield method is a static method of a thread class, and it can stop the current executing thread, and it will give a chance to the other waiting threads of same priority. In case there are no waiting threads, all the waiting threads have been lower priority, then same thread will continue to execution. The advantage of yield method is to get a chance to execute other waiting threads. If our current thread is taking more time to execute, allocate the process. So it depends on priority. So here, whenever you are saying the thread dot yield, it will check, is there any other thread which is having equal priority or greater the priority than the current thread? Then it will give the chance for that thread to execute, but you cannot guarantee that one. It all depends on the scheduler. It's a static method. So that's the reason. See, whenever I'm calling the thread dot yield, I'm not specifying that which thread it has to execute. Okay. Any questions? Look at here. Whenever you execute, the output might be different. Okay. So because that threads, we don't have the control. Whatever you say, it is not in our control. So any questions, guys?
Yield method is similar to like notify other or
No. Notify means it is telling inter-thread communication. Do you talking to other thread? You are telling based on the priority you are giving, but is it happening? No. Notify method will 100% make sure that all the threads will come back to execution, right? Notify all. But here,
notify.
yeah, so that means if on an object, if 10 threads are there, can I say 10 threads will come back to the execution at once? Yes. But here, you're just telling the thread which has a more priority than the current thread should execute. That's it. But is it executing or not? It is not in your hand, right?
Yeah. If all the threads having the same priority, then
those are lesser than your thread or greater than?
yeah, greater than.
Yeah, greater than, then any one thread will come can be given to the execution, but it depends on a scheduler.
What is the difference between the yield method and join method?
Join method will make sure that a thread completion, right? See, if I say in the main method, I will say here if I say t1 dot join, what happens? Can the main thread will start executing the t2? See here, Satish, right? So whenever I say t1 dot start, can I say independent path of execution will start?
Yes.
If I don't have this line number 22, can I say main method will start the T2, T3, T4 threads also?
Yes.
Okay. If I say T1 dot join, what happens?
It will stop the T1.
No, until the T1 is completed, the main thread will be waiting, correct?
Yes,
It will not start the T2, right? That is the difference.
Yeah.
Okay. So, any other questions, anyone?
Sir, if early method first, the execution will come. Suppose if the T3 thread will come to the run method, so there we have used the yield method. So in this case, the T3 execution will be hold or it will complete, and next will go to
No,
the.
it will. So it will check. So whenever the T3 thread is executing, you are saying thread dot yield. Is
Yes.
there any other thread which is having greater priority or equal priority than T3?
Yes.
Then that that thread will be given the access, and the current execution thread will go into a wait mode.
Okay.
Or for example, all other threads are having a lesser priority, then this thread will continue to execute. So if that is the reason, if you see, sometimes you are getting an output in middle, correct? See, some threads are executing and you are getting some output, correct?
Yes.
It is giving the chance so that other thread is executing. That's the meaning. Look at here.
Okay.
I've kept a high first and then thread name. Whenever you say thread dot yield, again some other thread is coming and executing it, right?
Yes.
Yeah, that's it. Okay. So that's all for today, guys. And that's all about the course. So I will by tonight, I will be sharing the consolidated notes. And do you guys need this interview questions document? Which has a question and answers?
Yeah, the short answers will be very helpful, sir.
Yeah. So I'll be giving the entire code, notes, and interview questions in. I'll put it in one zip document. I will attach in the WhatsApp group as well as in the portal. Okay. And I will share entire thing. And I have shared one link in the WhatsApp group, guys. So can you please provide the feedback? And thanks for those
Sure.
who has already provided. But I request others to please provide the feedback.
Yeah, sir. What is optimistic and pessimistic log?
I think you have joined late. We have already discussed.
Okay.
It's a concept only. There are no classes. Pessimistic lock is nothing but a normal class lock, object lock, etc. Pessimistic lock is nothing but there are no, very rarely the threads will execute the common shared resource. So you have to use a atomic variable to in the optimistic lock. In the pessimistic lock, whatever we are doing the locking mechanism, right? That is nothing but a pessimistic lock.
Okay.
Karthik, where exactly we can use that yield method? Is there any scenario we have to use that?
In my experience, I haven't used it.
Okay.
Most probably you will be using countdown latch, thread pool, this number of different threads creation. Those are the things that you can see. Most frequently used is executive framework and then the countdown latch and the lock mechanism. Synchronize also you can use, but lock mechanism is a preferable one.
Okay.
Okay. So if no question, that's all for the course, guys. And today will be the last day. And I will share by tonight, you can expect a note from me. And so do you guys are able to access this link, right?
Yes.
Yeah.
Yes.
So whoever is able to access, whoever is provided, that's good. And for others, please provide the feedback. See, because of this feedback, I was able to see in the previous classes, there are some people who provided the feedback. Based on that, I'm improvising like my notes or topics or the explanation, everything. So whatever the feedback you feel honestly, you can put it. I would not be knowing who has put what. Okay. Even if I know, it doesn't matter for you, right? Because say everyone, I feel that everyone has a scope of learning, right? Even the Java creators who have developed also, they will be having a scope of learning, right? So that's the thing. Like, please spend your 2 minutes of time and then provide the feedback here. And maybe by the first week of April, I'll be taking one free workshop on Lambda expression, functional programming and Lambda expression on free workshop. Okay, if you are interested, you can join. You will get to know what is a Lambda expression, what is the advantage of Lambda, etc. Okay.
Karthik, this Java 8, 9, 11 class is already scheduled, right?
No, it is not.
I mean, plan is.
Yeah. I'll be taking in maybe after design patterns are this data structures is completed, I can start that.
I could see that flyer on the mobile app, I think. Is the same one?
I have not told them.
Karthik, when will you start the Java 1.8?
Maybe in the first week of April.
Okay, may I know the timings?
Same in the morning, between 6 to 9 only. I mean like 6 to 10 only.
6 to 10. Okay. Actually, 9:30 we have React.js class and we are at 7:30 we are DSA call.
So after completion of one of the data structures at DSA, then only I can start.
Okay.
It is becoming difficult for me if I start in the morning, like to manage all of these three. Okay. So anyone is completed, like we had design patterns, we completed almost around, we are around yet 7 design patterns is left and another 8 of microservice patterns is left. So I think that will be completed within the first week of April. Even data structures also we have some topics to discuss later. I think we'll be completing in the mid of April both. And then I can start one collection workshop similar to the threads, complete details with the internal depth knowledge. And other one is Java 8, 9, 11.
When we can accept this one collections workshop?
So in the mid of April, first or second week of April. So before that, I will be keeping so on 1st of April or 8th of April, or like between like on Saturday, like first weekend of April or second weekend of April, I'll be putting a free demo classes on Lambda expression and then some of the collection things. If you want, you can join just to know the knowledge.
Sir, I have seen one of the WhatsApp message from you, like you're going to start MongoDB or some classes, right?
Docker,
So,
yes.
so I would prefer MongoDB because of no one teach MongoDB in America, sir. That is easy.
Yeah. So that
If
is
you
what
teach,
even I.
if you start means many people will interest.
Yeah. So that is a plan for me.
Yes. I'm interested to join MongoDB or Java 8.
Yeah, fine. Thanks. So guys, please share your feedback. Okay. Whatever you feel like, put your honest feedback. So it would improve me. Okay. Anything else?
Courses, can you please go down, sir? There's some online courses. Okay.
I have not told them.
Okay. Maybe in mobile app is there. I think okay, fine. As per your timings, they will adjust it.
Yeah. So if no question, that's all.
Sir,
How do you feel?
Sir, evening times, if it is possible, evening times also it's okay, sir.
No. See, I'm having. It is very difficult. Literally from morning to even morning 6 to 10. I've been speaking continuously for 3.5 to 4 hours. It is very difficult.
Yes.
Yeah. So I don't want to continue. Like this thread, I shouldn't have taken it, but when I have kept the thread workshop and many of the people are requested for this, so I have kept it. Okay. So, but going forward too, after completion of this, any one, I will start this one. Data structures and design pattern will be completing. One will complete by April 15th or something. So then we'll start 8, 9, 11 or collection workshop, anything. Okay. How do you feel, guys? Did you get enough knowledge?
Yes.
Karthik.
Sir, how to remember, sir, these are the things?
You have to practice or explain to someone else. By explaining to someone else, that is the best way to understand. And ask them to ask you the questions and then you practice it.
Karthik, this 8, 9, 11 one. Oh, the course fees, is it how much it is? I remember it is shown as 3,000.
No, not 3,000. I think somewhere around 4 or 5, but I don't remember. We'll let you know at the time of the course.
Okay, fine.
Yeah. I think only 8, 2,500 might be, but together 8, 9, 11, I don't know. You will get it. Okay. It's been a long time. I forgot it.
Okay.
Does anyone wanted to share any feedback?
There is no feedback, but early morning 6 o'clock, the class is very difficult to join because we are the US client. I am working for the US client, Karthik. So it is late night will be happen. So morning 6 o'clock, if you conducted, we are unable to join. So my concern, I am telling.
Okay, fine. Yeah. Anyone else? Any feedback? Yeah. If nothing, that's all for today, guys. Thank you all. Thanks for joining. It was very nice talking to you. I have learned a lot from you guys. Thank you. Keep practicing. And if you have any questions, put your questions in the group. The group will be alive. You can put your questions, and based on my availability, I will provide the answers. It does not mean that today after the class, I will not stop telling you and all, right? So you can put at any point of time, not only these threads, any Java question, Java related question, you can ask me through the group that we have. And based on my availability, I will provide you the answer. Maybe 1 day or 2 days, but I will provide you the answer. Okay.
Thanks, Kartik.
Yeah. Thank you all. Thanks for
Thank you.
joining. Have a nice day.
Yeah, thank you, sir.
Please complete the feedback.
Karthik.
Yeah.